All right, we are doing 9.03 for geometry today. And we're talking about proportions in triangles. So first, I'm going to give you a picture here of a triangle. And this is going to be B, A, E, D, and C. And we know that these two segments right here are parallel to each other. And I want you to first name the similar triangles. So figure out which triangles are similar to each other. So when you're doing that, we want to look at our parallel lines and find our corresponding angles. So if we look at our parallel lines here with this transversal, you can see we've got corresponding angles here. We also have corresponding angles over here. And both of the triangles, and when I say both, I mean this top triangle, ABE, and the large triangle here, both have, they actually have all three angles then, corresponding angles congruent. So now we know those two triangles are similar. So if we call the first one triangle, let's call it ABE, that would be similar to, and here pause the video and see if you can match up the corresponding parts. So A would correspond to A, and angle B would correspond to C, and lastly, angle E would correspond to angle D. So those are our similar triangles there, and they are similar by angle-angle similarity. We actually would have all three angles we could potentially get. And then I just want to set up the corresponding sides as well. So we know that side AB in one triangle corresponds to side AC in the larger triangle, so AB and AC. That would equal side AE over side AD. And then lastly, side BE would correspond to CD, the last two letters. I'm going to give you some numbers now. So AB is 15, and AE is 18, and AC is 20. So from here, I'd like you to find side AD. So we'll call AD X. All right, pause the video and set up a proportion and solve. All right, so to do that, try to do it so you can see the picture at the same time. We have side AB is 15 over 20 would equal 18 over X. And then we could cross multiply and we get X equals 24. Okay, so we know this full side is 24 from here. Now let's talk about what is your ratio of similarity here. So your ratio of similarity is the ratio of your sides. So the ratio of similarity, if our sides reduce here from 15 to 20 is our ratio of similarity. So 15 to 20, which I could reduce 15 over 20 to 3 to 4. You can write it as a ratio like that, or you could write it as a fraction. Either way is fine for your ratio of similarity. That would also be the same as my ratio of the perimeters. Same as the ratio of your altitudes. And the ratio of your sides is all the same ratio. And then if you talked about ratio of areas, that's when you would square it to be 9 over 16. Okay, so now I want you to find the ratio of side AB to BC, and also find the ratio of side AE to ED. Pause the video and do that now. Okay, so we've got AB. If we go up here, we're looking for AB to BC. So AB to BC. Now we know that this is 15 and this whole thing is 20, which means this is 5. And here we had, this was, so actually let's finish this one here. So we've got the ratio of side AB is 15 to 5, which would reduce to 3 to 1. Here, we know this is 24 and that's 18. This one's going to be 6 right here. So we do 18 to 6, also reduces to 3 to 1. So here, A to B, AB to BC is 15 over 5, or 3 to 1. AE to ED is 18 over 6, or 3 to 1. So now we see that the ratio is the same for these two pieces here, and then here and here. So that allows us to use something called the side splitter theorem, is what that brings us to. So that's our triangle proportionality theorem, or our side splitter theorem, which says if a line parallel, and it must be parallel to one side of a triangle, intersects the other two sides, then it divides them proportionally. So it's not saying necessarily that you have the same ratio as your ratio of your sides. Like in the one above, our ratio of our sides or perimeters was 3 to 4, but the ratio of AB to BC was 3 to 1. So we're not saying it has the same ratio as the sides, but it does divide them proportionally for this. Okay, so if you look at a triangle like this, so let's say this is Y, M, A, T, and R. If we know that these two segments here are parallel to each other, then we have some proportions that we can set up. So wherever that intersects those two sides, here and here, it's going to divide those proportionally. So then I know that if I take MA over AR, then that's going to equal the other side. So YT over TR. Or you could do it and say MA over, oh, we just did that one, MA over YT would equal AR over TR. So we know that this is divided it up proportionally wherever it intersects to the other side. So that's really important, knowing that it's often very helpful. We also do know that those triangles are similar to each other, so we also know that AR is equal, AR over MR would equal TR over YR. You have to really be careful on this one, though, is when as soon as you involve these two lengths, if you're finding the lengths of the segments that are parallel to each other, you no longer can use the side splitter theorem. That's when you must use the triangles, meaning you'd have to use this side over the entire thing equal to this over this. So be really, really careful. That's really what tricks students, is as soon as they start seeing those two parallel lines, given the lengths of those. So let's try one here. So find x. And they have to be parallel to each other in order to divide them up proportionally. So this is x minus 4. This is 4. Here's x minus 1. And down here is x plus 1. All right, so first pause the video and see if you can set up a proportion given those lengths of the sides. Okay, so again, there's multiple ways of doing it. Here, I'm going to do 4 over x minus 4 equals x minus 1 over x plus 1. So I did the top over the bottom equals the top, whoops, didn't switch, the top over the bottom. Or you could have done 4 over x minus 1 equals x minus 4 over x plus 1. Now go ahead and solve for x. All right, so you have a fraction equal to another fraction, so hopefully you're thinking about cross multiplying here. So I've got 4 times x plus 1 equals x minus 4 times x minus 1. And then you want to get rid of those parentheses, so we're going to distribute and FOIL. So we have x squared minus 1x minus 4x plus 4. I see x squareds and x's here, so I want to combine my like terms. And I want to get this equal to 0. So here I combine -1 and -4. And then I'm going to subtract over my 4x and my 4. Now the 4's actually cancel. So now I have x squared minus 9x equals 0. So this one's always a tricky one for students because you have to factor it, and it's different than the others, but it actually is a little shorter. So here you would take out your GCF of x, leaving you with x minus 9. And now draw your line, set each of those factors equal to 0. So we get x equals 9 and x equals 0. And just make sure that makes sense in your original problem because we are talking about lengths of sides. So if I put a 0 in here, that would be 0 minus 1, which is -1. So that's no good. If I put a 9 here, 9 minus 4 is 5. So those would all work if x was 9, but they would not work if x was 0. If you just had x equals 9 because you divided out that x, you would not get full credit. You must show that you got a 0 and then that you're rejecting it after that. All right, number 2. In triangle GEF, segment KL is parallel to segment EF. K is a point on segment GE. If KE equals x minus 3 and GK equals x minus 5, GL equals x plus 7, and LF equals 2x plus 3, find x to the nearest thousandth. All right, so first pause the video and draw a picture here. All right, so in your picture, we should have triangle GEF, and you have to be careful how you do this one because we know that we want KL to be parallel to EF. So if I make EF down here, and I know that K is a point on GE, so this has to be K over here, and then that must be L. KE is x minus 3, GK is x minus 5, GL is x plus 7, and LF is 2x plus 3. Now that you have that drawn, if you haven't already, go ahead, set up your proportion and start to solve. Now, as you start to solve that, be aware here, there's a big hint. It says nearest thousandth. So as you start to solve, hopefully you start to realize something. And I won't give it away yet, but go ahead and see how far you can get. All right, so I'm going to start with x plus 7 over 2x plus 3 equals x minus 5 over x minus 3. Now I know these two are parallel, which is why I can set that up and I don't have to add these two sides together like I did previously when we set up similar triangle sides. All right, so now we've got lots of binomials, so we're going to go ahead and cross multiply and FOIL all those out. So I've got x plus 7 times x plus 3 equals 2x plus 3 times x minus 5. Pause your video here and FOIL those out. So on this side, you should have gotten x squared plus 10x. So we've got, oh, I changed this. Something went wrong. I made this into a plus. It should have been a minus. So we should get x squared plus 7x minus 3x. So that would be x squared plus 4x minus 21. And on this side, you should have 2x squared minus 7x minus 15. Again, you guys would show the work and showing combining your like terms. Now I have x squareds and an x, so I need to get this equal to 0. So to do that, I want to bring everything over to the right side because I want to keep that x squared positive. So I'm going to go on to this next page. So here I get x squared minus 11x plus 6 equals 0. Now it said in the problem to round to the nearest thousandth, which is a big hint to tell us that this is probably not factorable. And if it's not factorable, then what do I need to use? Hopefully you're shouting out quadratic formula. So a good review of our quadratic formula here. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you should have that memorized. So now you want to substitute in. So we've got x equals negative 11, so that's positive 11. Show all your substitutions here, so negative 11 in parentheses squared minus 4 times 1 times 6 all over 2 times a, which is 1. Now in your calculator, you should type in this whole thing without the radical all at once, which should give you 97 over 2. And now we have two possible answers. So in your calculator, you want to put in 11 plus rad 97 over 2, and then 11 minus rad 97 over 2, and get a nice decimal. So here, if we add them, it should be 10.4244289. When you subtract them, and please make sure you do that, pause your video and subtract them if you haven't already, 0.575571099. And if I go back to my original problem and I were to sub these in, if I sub in a 10 for any of these would be good, but if I sub in a number less than 1 and then subtract 5 from that or subtract 3, that's going to give me a negative value. So here, I don't want to keep this one. I want to reject that. And then it said to round to the nearest thousandth. So tenth, hundredth, thousandth. So 10.424 would be your final answer for that one. All right, and then we want to also be able to go the other direction and determine if the sides are actually parallel. So determine if segment ST is parallel to segment PQ and explain. So I'm going to give you a picture. So we have 4, 6, 5, and 10. We want to know if ST, this up here is R, down here is P and Q. We want to know if ST is parallel to segment PQ based off of that given information. So to figure that out, we want to know, are they split up proportionally? Does S and T divide those sides proportionally? So we can do 4 over 6. We want to know, does that equal 5 over 10? So two ways. You could reduce both sides and see if they're equal, or you could cross multiply. You might be able to also tell right off the bat. So we get 4 times 10 is 40, 6 times 5 is 30. They are not equal to each other. So they are not proportional, which means segment ST is not parallel to segment PQ because segment ST does not divide the sides proportionally. And that was actually a Regents question, including the explain part. So very important that you can explain there. All right, and the last thing we'll look at today is if you have 3 or more parallel lines, so a theorem. So 3 or more parallel lines cut off proportional segments on any 2 transversals. So if I take, so this is number 4, if I know these are parallel to each other, and we'll call this B, E, and A, and here we have D, C, and F. So if I know that these 3 lines are parallel to each other, I know that I can say that it divides them proportionally. So let's say BE is 8, EA is 12, DF, so from here to here, is 24, and DC is X. How could I find X? So in this case, same thing as if you were to extend them and make them into a triangle, we know we have proportional pieces. So I know that 8 over 12 will equal X over this piece. Now, how do I find this piece? Well, if the whole thing's 24, I can do 24 minus X. Or another proportion, you could do 8 over the entire side like you could with similar triangles. 8 over 20 would equal X over 24. Either proportion would work here. Pause your video and cross multiply, solve for X. All right, so here you should have gotten X equals 9.6 for this one. So same idea as with triangles, but using the 3 parallel lines to do it a little bit differently, but same concept. And that is it for today. If you have any questions, let me know. I hope to see you all soon. And